So, good morning, everybody. Welcome to the second day of the SFSCon. I hope you are all awake and had a good evening yesterday, and now we can start with a new series of interesting topics. Now, in this track, the topic will be about public administration and GIS. And I'm very honored and to welcome Mr. Rafael Fernandez from the European Commission, so which is our first speaker who is going to introduce this track, and he will present us some open source applications in the fishery and maritime domain. So, Mr. Fernandez, can you hear me?
Good morning. Yes, I can hear you very well. Good morning. Buongiorno.
So welcome, and I give you the floor to make your presentation. Thanks.
Thank you very much. So just a few words about me. My name is Rafael Fernandez Font. I work in the Director General of Maritime Affairs and Fisheries in the European Commission as IT Operations Manager. I have been involved in some projects that have to do with open source. I'm going to present today 3 of them that we have released open sourced in the past years. And I want also to talk a bit about the strategy of the European Commission about open source. Let me start with the presentation. And I want to talk a bit also why is it important for the European Commission to do open source software with examples that I am more close with. So a few words about the strategy of the European Commission. The European Commission is increasingly participating more in open source development as a contributor. We develop a lot of software. We are a software powerhouse, mostly for us, for the European Commission. But some of these can be also useful for the outside world. Up until January 2022, it was difficult to publish open source. There was a complex administrative path that we had to follow, involving the hierarchy in order to make our software open source. We have, and we will continue to have, a central intellectual property team, which is helping us in choosing, for instance, the adequate license, and to be careful about which libraries we use in our development in order to be sure that we can then publish something. In October 2020, the European Commission published an open source strategy, and the aim is to contribute to the knowledge society by sharing the code that we build. Now, from 2020 onwards, there is a decision that the Commission is currently working on, and what I'm giving you today is a bit of a scoop about what is going to happen in the coming months, making much easier to make our software available to reuse. The procedures have been simplified. We are choosing a default license, which is the EUPL 1.2, something that the European Commission has developed, which is similar in some ways to GPL version 3. You will probably know better than me about this. But this is the default license. We can choose some other if we prefer, but at least there is some sort of a flagship license that we can choose. There will be an official repository for open source software for the Commission, and the personnel of the Commission, it will be made easier that they can contribute to external open source projects. So this is a bit the overall picture about how the European Commission is moving towards open source. I wanted to give you as well some examples of what we do at the DG Mare, at the Maritime Affairs and Fisheries DG, giving you 3 examples of things that we have done recently. One is the commitment tracker. There is a series of conferences that are called Our Ocean. The Our Ocean conferences bring together a lot of parties, a lot of countries that want to commit to improve the state of the oceans. And these commitments that they do, that can be actions that they are financing, that can be political priorities that are shifting, we want to track them. And we have developed a tool. I'm going to show you a couple of screenshots from this tool, where in a map, we are showing what sort of actions are being committed by the countries in order to improve the state of the seas. So this is just one view, the map view, and here this would be an example of a list of commitments that one of the countries that participate in the conferences is committing to. So The code of this application is public. You can find it in GitHub. I have put here some information about the technologies that we are using, and why are we choosing open source for this. The European Commission is contributing to our ocean conferences, and one way in which we want to contribute is to develop the tool that then will be used for tracking. And the best way that we can find in order to contribute is by making the code open source, because someone else will pick it up. The next organizer of the conference will pick it up and will maintain it. And then by making this open source, we have a clear way of contributing this piece of software to enable transparency about these commitments, because there is a public website that you can check where you can find this application embedded. So this is one of the examples, our ocean commitment tracker. We have another two applications that are open source or going to be released very soon open source, that have to do with fisheries data exchanges. Okay, so now I touched the maritime part. Now I'm going to move into fisheries. And when we're talking about fisheries, something that we do is to control the fishing activity of the European fleet, of the European fishing fleet. They have to send the positions of the vessels. They have to send the fishing activity, what they are catching. They have to send the information about the vessel itself. So if the vessel changes owner, this needs to be communicated to the European Vessel Registry. And there is exchange of licenses, requests, and permissions. So if a vessel wants to fish in a particular part of the sea, they need to issue a request. And all this data travels through our transport layer, through the FLAX transport layer. FLAX stands for Fisheries Language Universal Exchange. But this is basically the tool that allows for a secure exchange of fisheries data between European member states, the Commission, and third parties. We are also involving, for instance, Norway, or countries with which we have an agreement, such as Morocco, Mauritania, in order to fish in their waters. So the idea is that we all communicate through this tool. This tool is implementing a specific format, which is the UN FLAX format. And there is an obligation by the European Commission for member states to use it. It's based on international standard, and the business domains that you can see on the right is what I have just explained. So the positions, the information about the vessel, and we have some others that we are rolling in, such as inspections, and we also have a layer of master data. So if you need to know the official list of codes for the fish you are fishing, you can query through this system to the central services, and you will receive a reply for your system. So this is what it does. And this piece of software has been developed by us, by the European Commission, and it needs to be run in all of the member states that communicate with us. And it creates a sort of a network, right? So voilà, so they need to be running this software. This is one screenshot of how it looks like the monitoring site at our node, at the node of the Commission. This is the amount of data that we are moving daily, approximately 450,000 messages. And you can see the nodes that are connected, what is the status when I took the screenshot a couple of days ago. No? So we control who is connected, if they are correctly connected, and what traffic we are getting in and out. And the FLAX transport layer is also generating a community. So this software needs to be installed and maintained by member states. We do have a team of developers, a small team of developers, 3 developers plus 1 quality assurance engineer at the Commission that is developing and maintaining this. But member states need to be running this. So in the end, we have a community of people, around 180 people, that need to be running the servers, upgrading our software, following our instructions, and feeding back as users about what are the new improvements that they would like to see in the software. So we do have a community which is quite lively. We have a Slack channel where we have all these people helping each other about getting installations and grades, communicating with the support team and with the developers. And the Flags Transport layer has already participated in several open source actions. The European Commission prepared a hackathon and a bug bounty program in 2019. We participated in that. And we have the open source release plan for 2022. So it hasn't happened yet. We have had to incorporate other priorities, including doing a large revamp and rework of the application, because at the moment when we say we want to release this, the developers take an extra pride in what they are doing, and they say, no, we are not going to release this because the quality is not good enough. So we have had that, and during 1 year we were doing a large revamp of the application. So that's a good signal of how making software open source feeds back positively into the quality of the code when you have a team which is committed and has ownership on the tool. We are going to release this in a GPL version 3. And why are we choosing open source for this? Because it's going to make it easier to follow the EU policies on fisheries management. Right? So we are imposing the use of a tool, and at the same time, we want that it's as easy as possible to work with it, because the end result is going to be better fisheries data that will allow for better policy management. So this is a policy tool. Open source for releasing FlagsTL as open source is a tool for better fisheries management. Similarly, I'm going to move on to another tool that we call Flags FMC. It's called Flags, it's part of the same family. But in this case, this is not the transport layer, but what we call a business layer. It sits on top of the transport layer. And it's a software we use to visualize the positions of the vessels and the activities at the European Commission. At our backend, what we will have is a sort of map where we can see where the vessels are and what they are fishing. This software was started in cooperation with other countries, with Sweden and with Belgium. So it was co-created during the last years, and we are currently using it in the European Commission. We recently rolled it out in production, and this is an example of what you can see there. So we get the vessels, what they have is, they used to have some sort of paper logbook where they were taking note of everything since the vessel went out of port and what they were fishing, and when they came back, they did some reports. Now we get everything electronically into the system and into our application. So this is also currently available in GitHub. And again, why are we making this open source? Because it will make it easier for other parties to comply with the policies that the European Union is imposing or suggesting / imposing. We deal also with third parties. So it's not only forcing member states to use this, but also trying to entice other parties, Norway and the third parties I mentioned earlier on, such as Morocco, Mauritania, and several others, with which we have signed an agreement of sustainable fisheries. We want to entice them to follow the way we work, to follow the policies that we want to put in place. And in order to do that, we could contribute by giving them this tool, by making it available for them to use it and to work in the same way that we work. So again, it's a tool for policy. So these have been the examples that I wanted to give, and I wanted to finalize with one a bit different element, which is another potential use we see for open source down the line. That could be to enhance and to optimize the way we are spending money in general in fisheries in the European Commission. There are some funds, such as the European Maritime and Fisheries Fund, that the European Commission prepares and gives to member states. And some of these funds, they are being spent in IT. So we have made a survey to know what they are spending this money on. because we believe that they might be spending money, all of them, in a very similar thing, which is software for fisheries management. We have seen that software accounts for 60% of all the money they spend on IT, and we believe there are opportunities for savings in case we discover that in reality they are spending the money on the same thing. So we could be tying the spending to releasing something open source, or just forcing them to apply an open source solution instead of multiplicating the spend. We are continuing this work in 2022 to see what we find. This is what I wanted to mention. Some examples about how we use open source, mostly as a complement to the policy that we want to implement, in this case in the fisheries domain and the maritime domain.
Okay. Thanks a lot, Mr. Juan Perez, for the very nice presentation. And it's fascinating to see how the reference organization here in Europe, the European Commission, is also using and committed to use open source, but not only open source, also the open standard was also a topic here. And thanks a lot for your contribution to the conference. Thanks a lot. For the audience, we will start in a couple of minutes with the next speaker, so 3 minutes. Thanks. Okay, we can start again with the next speaker. Next speaker is Roberto Reale from the organization Utopian. I hope that I call it correctly. The topic will be open source for digital transformation, infrastructure for digital transition. So it will be very interesting also in this time. So, Mr. Reale, can you hear me?
Yep, totally.
Okay, so I give you the floor and you can start with your presentation. Thanks for participating.
Okay, thank you. So I'm Roberto Reale. This is just a short conversation about open source. I don't have slides because I don't like them. I have to be honest. I prefer to just discuss this topic in a more lively way. Open source. So it's clear, I think, to everybody that open source is not just software. Today we have, of course, open source hardware, but we can also have open source standards, open formats, of course, open data. We are widening the scope of open source more and more. And of course, there is also this concept of open knowledge, open revolution, but we will stick to, let's say, a more strict meaning of the word open, because the topic of this conversation is about the EU strategy for open source. We know that there is the European Commission just recently published a open source software strategy for the 4 years from 2020 to 2023, and also a very comprehensive study about the impact of open source software on the and hardware, in this case, on the EU economics. So this is the latter is a very interesting study that I advise you to read if you are interested in the topic. It was also there are some contributions by the Fraunhofer, by the Open for Europe. It's very comprehensive, and it is also not tackles different point of views. For example, the competition point of view, the so-called independence, technological independence, which is now a very hot topic in Brussels. So. Why the title of this discussion is open source as a utopia? Is it a utopia? Is it something that can indeed help the European Union to reach our goals of course, technological independence and economic growth? Well, this is hard to say because I want to stress this fact. We can, when we say open source and when we say that we want to adopt open source, well, there are different meanings in this expression. Because first of all, we can just be users of open source software, and we, as for example, as the public administration, can adopt open source software products. For example, in the past, there was this huge effort to adopt, for example, OpenOffice as an alternative to Microsoft Office, of course, or Linux on our desktops, as an alternative to Microsoft Windows. So this is the first, let's say, first level of open source software adoption. Then there is a second level where we actually write open source, where I'm focusing on public administration, decide to adopt the open source model, hoping that we can reuse the software we write, and that we can tap into a kind of scale economics. And then there is a third level, which is probably the hardest one to reach, where we actually participate in large-scale open source projects. And this third level is probably the most interesting one, because if we think of the most famous, most important open source project at a global level, for example, let's think about Linux, or about infrastructure level projects such as Kubernetes, or maybe in the past few years, OpenStack, which is now a bit less, let's say, a bit less key as far as infrastructure is concerned. And when we think about these projects, we have to keep in mind that who is contributing most is not just individual developers across the world, but indeed the very same big players in the digital market. If we this is especially true for the Linux kernel, which is of course maybe the most important piece of open source software ever written. If we look at the statistics of how many lines of codes are written by who, we'll see that the top, probably the 20 top contributors are companies such as Intel, Huawei, Microsoft, and so on and so forth. Why is this the case? Well, for very simple reasons, because these are the same companies that use Linux as a key piece of software for the value chain. Basically, for example, we are talking about companies that use Linux to power cloud-based products, or to power, for example, mobile device, or industrial devices, or supply chains, and so on and so forth. So, of course, they do not contribute to the Linux development just for the sake, of contributing to a beautiful, project, but because this is part, again, I want to stress this, because this is part of their business project. So if we, as Europe, as the European Union, and more specifically as the public administration, public sector in the European Union, if we want to do the same thing, so if we want to be successful in this effort, to be part of the open source movement, we have to adopt the same. We have to adopt exactly the same approach with open source, because so this is the third level. Okay, just to summarize that again, because till now we have seen that the first level, so just using open source products, office automation products, and so on and so forth, is not working so much anymore, and that's because software as a service products, which are not which use a completely different, of course, distribution model than traditional software. It's just too difficult to use as open source. So in the shift for traditional, for example, open automation, office automation products to just cloud-based suites, so just software as a service products. Well, the traditional way of trying to adopt open source is not working anymore. So on my desktop, I don't have any more just a Microsoft Office installation. I basically have a cloud-based equivalent of that, and open source products just don't have this feature. So the first level, which was the let's say the early 20 way of using open source, is not working anymore as far as the public administration is concerned. The second level, so again, publishing software, the software we build, the software we ask our suppliers to write for us publishing that software as open source, hoping that somebody will reuse it. I can speak for Italy, for example. For the Italian case, there is quite a sizable kind of catalog for reusing. It's not working at all. This is just software, because this is not the way open source model works. It's not just a matter of putting a label, putting an open license onto a piece of software and publish it on GitHub for that piece of software to become open source. I mean, it's formally open source, but but there is no community attached to it. There is no community that is interested in that piece of software, and this means that that piece of software basically is not open source. It's just a let's say kind of proprietary software with an open source license. So the third level, again, which is participating in the global open source movement by participating to actual, to large scale open source projects, is this is my I'm a strong believer of this fact. The third level is the only one that we can tackle with success, but this is a completely different, let's say, way of doing open source software than before. Of course, I'm still referring to a point of view from the public administration. So, if we want to be successful, we need to, in a way, copy the approach that digital companies across the world are adopting. But in order to do that, and this is why is this important? Because if we read the report we were talking about before, so the study about the impact of open source software and hardware on the EU economics, the prospects are not that bright. The impact, as far as this report goes, is quite small, and there is this. I mean, by reading this report, one gets the feeling of just a huge waste of of time, of efforts, of resources, and this is so. This is not. This is something that we have to change. But if we want to tackle open source in the way that big companies, that large companies do, we need to understand that that market is the same as any other market. So we need money, we need investments, we need knowledge. We need knowledge. This is extremely important. So we need to build capabilities within the European Union in order to not just in order to publish our software as open source, but to be part of the open source movement at the global level, and by competing with the big players. So this can also be this can also pave the way for a more advanced model of so-called technological independence, that again is this kind of mantra of the European Commission. It's important to understand that, for example, if we want to have so-called European cloud based on European software, we cannot do that by adopting that mindset. We cannot build a European cloud, calling it European cloud. We need to be part of a global cloud market which is based, of course, on open source products. Because if we look into data centers of every large player in the cloud market. Everybody is using open source software for their infrastructure. So we can build a European cloud, provided that it is a cloud, it is a global cloud, provided it is something that can compete with others in the world at the global level, and by using products that are not just developed in Europe, but products that are developed at the global level by a community of which we as Europeans have to be part. When I say we as Europeans have to be part, I'm not referring to just individual efforts, just individual developers, which are, of course, this is of course something. How can I say, it's desirable. Of course, we have so many extremely good individual developers, individual contributors in Europe, but I'm referring to an effort of the European players, of the European market players. So again, just to summarize, because we are close to the end of this discussion. Just to summarize, let's say bottom line of this discussion is that the open source market, if we want to play into this market in a successful way, and not just limit ourselves to using just kind of wishful thinking models, just toy models of open source. So if we want to enter this market in a successful way, we have to understand that it is a market like every other global market. And again, to be successful, we need investments or money, we need knowledge, capabilities, and we need a coordinated effort by everybody in the European Union. Thank you.
Thank you. Thanks a lot for this, let's say, for this statement about also your point of view about how we should, let's say, use open source in the right way to create this open market at the international level. So thanks a lot. I would like to say goodbye to Mr. Reale, and in a couple of minutes, exactly in 2 minutes, we will welcome our next speaker. So 9:40. Thank you. Okay, so let's start again with the next speaker. Next speaker is Grazia Cazzin from the Knowledge Labs engineering group. So we had already yesterday a presentation about this, I would say, open source experience that you have with your products. And as far as I understood, now with this presentation, we are going to know a little bit more about real use cases based on this open source project or product. So, Mrs. Katzin, can you hear me?
Yes, I can hear you.
Okay. So please, the floor is yours.
Thank you. Thank you. Good morning. I start sharing my screen. Okay. I want to show you some real use cases we working on using open source for industrial purposes on data on the data analysis domain. I'm Grazia Cazzin from Engineer Group, as I was introduced, and I'm in charge of the offering in the data and analytics domain. And I'm also the leader of Knowage, the first European open source project for business intelligence and data visualization. Engineering, my company, is the first Italian private company in system integration, and we are more than 12,000 employees. And we are an international player working in every market sector. And with the relevant investment in research and development, we play a leading role in Italian European research, coordinating national and international projects thanks to our 6 R&D laboratories and thanks to a network of scientific and university partners across Europe. We invest in research and innovation to support the continuous, rapidly changing market. And as you know, many times innovation comes from open source. For sure, that's it in the data and analysis domain in the last years. Herein, we are part of a specific data and analytics competency center based on a multidisciplinary team of professionals that manage the entire data lifecycle, from data collection and management up to quality and governance and up to the best visualization of results. And moreover, we are an open source provider, not only an adopter, because from more than 16 years, we are leading and developing an analytics and business intelligence suite, actually named Knowage. So let's start by trying to say what Knowage is in a few words. Knowage is the only open source suite that satisfies the ABI criteria defined by Gartner. That means it fully supports the BI requirements and the modern needs such as self-service and ad hoc reporting. Moreover, it offers mashup capabilities to combine data coming from different sources, high-level customization options, so as you can reach exactly the data experience you want. And obviously, Knowage natively supports multi-devices usage, and more interesting topic, it allows you to get data from various data sources, even at the same time, so as you can use any data for the goal you have in an open architecture that makes integration tasks easier. And this subject is an important enabler if you are looking for a product to embed in yours, as for an OEM solution. Knowage, as you know, is an open source suite, but not only because you can find the source code available, but also because it adopts open standards. And for sure, you can guarantee the user thanks to facilities and support you can have with the Enterprise Edition. At least it can work on-premise and on cloud, following your data service strategy you want. And now have a look at 2 different use cases we worked on using a full open source stack for industrial purposes and data analysis domain. The first one is about a quick project we developed for an Italian region at the time of the emergencies last year when the pandemic was so raw. First, we started with the descriptive analysis because the Ministry for Health defined measures and KPIs every region must send to the central government to collect information, and not only from a clinical point of view, but also as far as concerned the efficacy and capacity in handling the emergency. These information were useful, first of all, to local administration to better understand its capacity and potential faults of its services. So we developed a set of ministerial indicators to figure out how things were going, also from an organizational point of view, so as to improve effort, whatever they need. Each measure had different logic and rules, so the main effort was to set up a common management to show results and be ready to add new measures without rework, because as you know, at that time, rules changed every day. So here we work with data coming from local units, and we built a very flexible model in a short time, making the local government ready to know how it was performing managing the emergency and ready to easily provide data to the central government. We did, as I said, in a very short time using a full open source stack that because of based on structured data only involved PostgreSQL as a DBMS and Talent Open Studios ATL and OH for dashboarding and data extraction for the central government. The second step was in the clinical area to predict the pandemic trends. Especially for intensive care units, the urgent questions was to know how many new entries there will be, so as to organize the right service and or set new strategies to avoid the collapse of the medical structures. So the goal was to predict the key indicators in terms of currently positive, R-Conti, intensive care, number of healed, number of deaths. And in that case, the end user was the decision maker. So he needed to have this prediction anytime, anywhere, and the mobile usage become the first option here. And of course, forecast and prediction had to be really reliable. To achieve these goals, internal data were not enough because local trends couldn't describe a global pandemic scenario of the world we live in. So we started using not only open source, but also open data. And we used Italian open data from the civil defense that described Italian trends at national, regional, and provincial level. We used demographic data from our ISTAT on the Italian civilian population. And we used global data from the Johns Hopkins University. This way, and starting from SIR models already available as Python libraries, we developed an optimized and self-adaptive model. Moreover, we used internal data from the region to apply corrective strategies and optimize specific phenomena such as territorial differences, temporal dynamics, and specific behaviors. And to validate the result, we used models to measure the error, but most importantly, also to have to be sure the end user understand the potential and the result, we developed dashboards able to compare the prediction with the subsequent real data that were coming over time. The result was so satisfactory that we are working now to handle the vaccine data within the model. And here also, we always do that using open source tech based on PostgreSQL, Talend, NoEdge, and Python. Here in this short video, you can see the result, also in terms of usability and data visualization, based on the mobile-first paradigm. Very easy and intuitive, no? to use even for unskilled people. Prediction were not shown to data scientists here. We have more analytical dashboard for them. But here, the complex results become very easy to use and understand for the end user, so that he can immediately understand what he needs to act upon. And the mobile usage is guaranteed and immediately, and the user can immediately look what he needs to understand and to decide what he has to do. The second case is about a cross-industry solution we developed starting from the distancing measure requirements. Again, thinking about the needs of the pandemic, where people can't stay in contact tomorrow. SafeAI is so our AI-based video and image analytics solutions to monitor that social distancing is maintained by people in public places. It can be used to protect public health by helping people comply with social distancing measures in COVID, but also in post-COVID lockdown phase. SafeAI works with video from surveillance systems and analyze humans in real time to count people within in a certain area, to evaluate the size of that area and the number of people inside, providing alerts if the ratio is over the threshold, evaluate the distance between people, sending alert if there is not enough distance and space between them, and detect people without the right personal protective equipment, the mask, just to start. Here you can see a picture of the logical architecture in which we adopt different strategies to handle with machine learning and artificial intelligence models a continuous video streaming to avoid unweighted breaks and waiting time in the video stream. We worked splitting the flow into fragments, enrich each fragment with machine learning and the artificial intelligence logic, and combining the results in a new and continuous stream that we show as a result. Over there, we detect and count people in a certain area, providing alarms if there are too many. And we evaluate the distance between people, 2 or more, sending alarm if between them there is less distance than certain thresholds. And as you can see here, we built an end-to-end application based on NoEdge's user interface, where you can link a video camera, or you can, as we are doing here, upload your video to analyze it for the different purposes I said, always having the chance to change the point of view and collect the detected alarm. Here I uploaded the video. It was analyzed by our machine learning and artificial intelligence models, and we divided the video and the fragment. As I said, we build the new one with the marker provided by the machine learning and the artificial intelligence models, and we look at the result combining the small fragment. On the other hand, we We evaluate and detect alarm, we count them, and we provide an alert system here where the desired people can receive immediately by email or other system the alarm, and some dashboard to look at the result, also in terms of historical trends. Also here we work with open source using also NiFi, Kafka, and Kubernetes more than Python, Postgres, and NoAge. CFIE was created in pandemic time, but can also be useful at normal time as instance to estimate the number of people waiting for our services or people at an event and so on. So, going to the end, what are the benefits of using open source for every kind of enterprise? We are talking about professional open source, which means high quality and trust. Open source, as you know, drives innovation, is open, and makes you free to choose the best partner you want to work with. Open source helps the open competition, where every partner has the same starting cards. But moreover, thinking about public administration, I think that some other values can be considered. With open source, you can have reuse by default, because everyone can use it from the beginning. And by choosing open source when possible, you support and contribute to create value for everyone, not just for someone. Open source has an open roadmap by default, because everyone can contribute by taking part in the community. And we can also consider that we have European and even Italian best-of-breed open source solutions. And last but not least, it would be appreciated that public money will generate public value, a kind of shared return of the investment for citizen and also local company, PMI, and so on. So that's all. Thank you, and you can meet our team in the seminar area foyer.
Okay, thanks a lot for this nice presentation. We have also your colleagues here that can, let's say, share also the fact that you have this
Of course.
stand.
Yes.
Maybe you want to add
If you are interested in knowing more about knowledge, you can find us on downstairs at OW2 Knowledge desk.
Okay, thanks a
you.
lot. And in 2 minutes, we are going to welcome our next speaker. So thanks a lot, Mrs. Katzin.
Welcome.
Okay, so next speaker is Anisa Cucci from Wikimedia Italia. And there is, I think, another very interesting topic, which is about mapping. And in particular, she will tell us about something about collaborative mapping for Openstreetmap. So, Anisa, the floor is yours.
Hello? Okay, that was a test. Hi everyone, and thank you for attending my very brief presentation about the Tasking Manager and OpenStreetMap extracts for Italy. So, first of all, I'd like to mention that these slides are made collaboratively as the projects that I will be talking about, because the developers have also contributed. So, Anisa Cucci, I work as a project manager for OpenStreetMap for Wikimedia Italia. I'm an OpenStreetMap contributor. I'm a member of the OpenStreetMap Foundation, and I'm also part of one of the working groups, which is called Local Chapters and Communities Working Group. I'm also a Cosmopolite member, which is a new group dedicated to diversity and inclusion within the Italian OpenStreetMap community. So, OpenStreetMap, before starting the presentation, I'd like to very briefly introduce you to OpenStreetMap. I know some of the people who are here today already know what OpenStreetMap is, but for the ones that are new and haven't heard of it, OpenStreetMap is a project born in 2004 in the UK, and it was created by Steve Coast. It's a project of collaborative mapping. It's a map, an editable map of the world, completely released with an open license. It is also the database, the biggest database of free geospatial data of the entire world. It is also a global movement, and it has lots of communities all around the world who contribute and do all these things and add things to the map with the aim of having a free map of the entire world, completely, an editable map of the entire world, completely released with an open license. So this is the objective why people are contributing to OpenStreetMap. Wikimedia Italia, the association for which I work, is an association that works in the dissemination of free culture and free knowledge in Italy. Wikimedia Italia is a local chapter of Wikimedia Foundation since 2005. You already know some of the projects. One of the main projects is Wikipedia, but there are like other 12 similar projects to Wikipedia, like Wikidata, Wikivoyage, and lots of other very interesting projects. And it serves also as a local chapter of the OpenStreetMap Foundation since 2016. This means that Wikimedia Italy supports and serves as a legal representative of OpenStreetMap in Italy. It means that the association supports the Italian community of contributors and users, and by having different roles, one of which is mine, and also other roles that are covered by volunteers, like the national coordinator and also regional coordinators. We help organizing events, conferences, mapping parties, which are our events where we start mapping and, adding things to the maps and, distributing free knowledge and all we know, sharing knowledge. We finance the software developments and we maintain infrastructure, some of which I'm going to talk to you about today, and the other ones, we can cover today, but I'm always happy to explain at some point. So this is what Wikimedia Italy does for the Italian community of OpenStreetMap mappers. The Tasking Manager, this incredible tool that I'm going to talk to you about today, is an open source software that helps to facilitate collaborative mapping in OpenStreetMap. It was firstly developed by humanitarian OpenStreetMap team. OpenStreetMap is a very huge project, and the humanitarian side of it has developed this tool to help facilitating their activities. It is maybe it seems complicated when you listen to it, but it's a very easy tool. And we're going to go through the second part of this slide with slides and with images, so it is more understandable. So it basically divides a mapping area into small tasks, and they could be completed very quickly. It shows the tasks that should be mapped, validated, or that are completed, and it also provides statistics. It is a very interesting service that HOT, Humanitarian OpenStreetMap team, has developed, and we use it a lot in the Italian community. Before going to the more practical part, I have a few technical information that I'd like to share. So the Tasking Manager was adapted by Wikimedia Italia for the Italian community. We used as a base the code that was actually released under an open license by this HOT team, the first one who developed it. It was quite complicated to adapt the tool in Italian because there were lots of difficulties for the developers team. We had a collaboration with GIS, an Italian startup who worked for the Tasking Manager, and they did a lot. We currently have the 4.4 version, which is the latest version released by HOT, Humanitarian OpenStreetMap team. And to develop it, to adapt it in Italian, there were 20 open issues on GitHub for the main tool because there were lots of things not completely correct with the main tool, with the source code of the main tool. So 10 of them were closed successfully, and 8 of them were developed by the Italian developers, even though we are talking about an international, global level in this case. There were done lots of customization, documentation, Docker improvements, and lots of meetings with the Tasking Manager main developers because lots of things to improve. So, what is the usage of this tool? The main usage and why it was created, it was for emergencies, because this is the tool that Humanitarian OpenStreetMap team uses for their field actions, well, actually for mapping places where there are natural disasters, earthquakes, and then NGOs go and use OpenStreetMap that is mapped by HOT for their action in field. And we in Italy have been quite lucky because we haven't had lots of emergencies, but we have used this tool for our mapping parties, for events, for birthdays, and we actually just invite the community to map together. We have used it for trainings, to do courses to teachers and students, or to scouts, because we have had several collaborations, and also for specific mapping projects. For example, the Alpine Club has used a lot in the past the Tasking Manager to facilitate and to manage their collaborative mapping for trails in the mountains. For example, one case where we have used it in Italy for an earthquake, for an emergency, was during the earthquake in central Italy, and the community was right away activated and started to improve and to update the map in the area right after the earthquake, and this is how it works. So this is the main page with the projects. You can see different projects there, and also the map that you can navigate. Let's say we choose one of them, which is Improve Asti, a project that we currently have and is quite active. And, oops, whoa, no, I didn't mean to change it. I needed this one. So these are types of mapping here that I'm not very good at. pointing, shows different things that can be mapped, and you kind of redirect the work that you want to be done in the direction that you want to, well, in the right direction. So this is a page with instructions, and you can actually have a more detailed instruction, and people understand what they should be doing in this project, and also the map. So what I was talking about earlier when I was saying that you divide the mapping area in tasks, means that you divide this map in squares, and you can see if they are available to be mapped, they are ready to be validated by expert mappers, or they need more mapping, or they are finished. And then you have all the work, all the process kind of tracked, and you know how, well, how much work is still left to be done. And a good thing that can be helpful for, okay, so you choose a square and you map selected task, and then you are on mapping mode on. So this is how you start mapping. You start drawing things in the map and adding information. Well, we don't have lots of time to go into detail in this part, but I'm happy to explain anytime. You also have a dashboard in the tasking manager, which can be really helpful if you'd like to have statistics on what has been done and the progress of any kind of project that you'd like to create. So it's quite a powerful tool that Wikimedia Italy has completely developed and, well, made available for anyone who likes to use it for free. And of course, everything is released under an open license. Future updates for the tasking manager, we have thought about having always updating the latest version, so this is something really basic. We are going to do some more customization and documentation on how to create projects. Another service that we have developed and adapted for the Italian community is Openstreetmap extracts for Italy, which is data sets, huge data sets of the whole country, of specific regions, province, or even municipality that could be downloaded in different formats. These data sets could be downloaded and used by professionals, researchers, developers, and there are different formats that you could download them. It's raw OpenStreetMap data. So it's OGC geo package is a protocol binary format, and Osment OBF format that are the three options of being able to download this data. The interface is really easy. It is possible to either navigate on the map and choose an area and download that data. As you can see, the blue buttons are how, like, you just click and you have the data. You can either search, because there is a search box, and also a drop-down menu that you can go through different regions and then find the city you'd like to have the data for. This is quite an interesting service. So far, this is how it works. It's very user-friendly. And for the future, we have thought about adding a timestamp for the creation of downloaded extracts, so people know when it was last updated. Anyways, they are updated daily, so they are always really updated, but still would like to just give the information for people who'd like to know. We are going to generate thematic extracts, which we are going to decide together with the community what they will be and which ones we are going to choose. For example, only, let's say, only house address numbers or different data sets, but not everything available, just thematic possibility to choose thematic options. We are going to have a dashboard to show the chronological progress of the quantity of house numbers that we have in OpenStreetMap for a specific region. It will be either for region, province, or municipality. And we are going to also have implement an analytic system, which is not going to track data. It's only going to have statistics, and we're going to base it in Matomo, which is an open source tool. You can find all the information on the GitHub page of GIS-Devio, this startup who has done all the development, a huge amount of work. And I would like to only share the fact that the OpenStreetMap extracts are released under the GNU AGPL v3 license. In the meantime, the tasking manager is under the same license that the developers have released it. So we have adapted it, but still, of course, maintain the same license. And thank you. I'd like to thank the authors as well, because they have contributed to create these slides. And thank you for listening. I'm available for any kind of question, information. So feel free to ping me. I'll be around the conference. Thank you.
Well, thanks a lot for the very nice presentation. It's really fascinating to see this tasking manager is a sort of Kanban for mapping, I would say. So thanks a lot, and we are going to start at 10:20 with the next speaker. So thanks a lot. Okay, so let's continue talking about mapping. And I'm very glad to welcome Marco Montanari from the organization Open History Map. And he's going to present something which is, so as far from what I read from the abstract, very fascinating. So the idea to create maps of the past through open source. So Marco, can you hear me?
Yes, I can.
Okay, so the floor is yours.
Thank you very much. Hello, everyone. Let me present our project. Here it is. Okay. So, and let me do this as well. Okay. Open History Map is a project that we launched around 2016, and it has the aim of a creation of a tool chain and a tool set to convey modern history and all history with modern web GIS tools. And in that, we want to create also additional tools as well for digital humanities, research historians, and archaeologists. The aim is to represent history in several ways, and it's complicated because history has a problem with detail. We have a problem with depth of analysis. We have a problem with vicinity, meaning that if you look at one place, what happens around it is sometimes more complicated to find out than in the big city or in the very analyzed area in a specific moment. For example, diachronic historical research was invented by Thomas Jefferson himself for the analysis of Native American history, and it was basically forgotten until only recent times, because it also the way history is analyzed is also very very important and very time dependent. So we have two orders of problems, like Anissa right now showed you. Open History Map contains a lot of information, and every time we look at a map, we could look at different ways to interpret the world. And this is, for example, the difference between Google Maps and Openstreetmap. In Google Maps, we have a more business-oriented point of view because Google is selling advertising. While on the other hand, Openstreetmap has a more data-oriented point of view, which is, as a software developer, way more interesting. Also for getting the data and exploring the data and using and reusing the data in several ways. So a typical approach to the past is, well, oral history says that back then that was all countryside, but back then what? I live in Bologna, and this is a beautiful map of Bologna in 1588, and we can see the walls of Bologna that are exactly the same as they are now, only the city is inverted because you went into the city from Porta Galliera, which is this one in the just below the door to the city that is in the lower part of the town, which is in fact in north. But this is not very important. What we can see is that the city we see here is completely different from the city we've seen in the other image. One other element that changes over time is the way the city itself is used, because in 1588, in the middle of the 15th century, we can see that the city itself that changed over time and was way more self-sufficient, meaning that it relied a lot on gardens and spaces within the city. On the other hand, we have an overview of a map that is way more representative of the specific elements. Basically, it was a representation of the grand tour that rich people could do, and a way to express and to convey the elements of the city that maybe somebody could never see because they could never move from their place. It is very important because obviously over time, the way we represented cities changed a lot. And so what are we working with right now? The maps, for example, in Wikipedia have several ways to convey information from the thematic maps, political maps, strange projections, but often the designs are scanned and are customized and cannot be translated or are not uniformed as a representation. But Wikidata, for example, gives us a beautiful element, which is its ID, which is way more important than it may look like, because being a single element can enable us to define interconnections between information in several sources. So our approach to the map is to go towards, let's say, data packages that are exported and exposed through from academia, meaning that academia itself has, over the last 30 years, created an enormous amount of data sets that are often lost, not updated, and put somewhere on the web that can be that is no longer formally usable. And so what we try to do is we try to use open source software and open data, historical open data, to transform these. This is, for example, the always Bologna, but the cadaster of the 1835 Gregorian cadaster, held in Rome and in the state archives. We try to use open source software and open source infrastructures to work on this map and to elaborate this map and make these maps, because there are several maps of that, available to the end user, not being simply pyramids of tiles of ancient maps, but transforming them and vectorizing them into something that is modern, that is usable, and that is exportable, and that is integratable into something else. So the information architecture behind this infrastructure is based on an approach that is similar to the one of Openstreetmap, where we can have specific tags that represent our items, but it also has a slight difference from Openstreetmap itself, meaning that we have, for example, a starting validity date and the starting and an ending of the validity of our object. We have a reference to the Wikidata item, and we need always to have a source information for our object. Being, again, we have the reference to academia, so we have to reference the object over time. Obviously, we have the geometries, the name, the category, and so on. But this is very important because the source itself, for example, gives us the ability to differentiate the kind of reliability we have in front of us, which can be a primary source, so it's a dig or field research, which has an enormous reliability. We have a secondary source, which means that we have a reliable historic source or a review of other researches, or we have a tertiary source, which means we have oral tradition, meaning back then it was completely different. Back then it was all countryside, or non-reliable historical sources, which can be sometimes a problem because they tell stories that are not absolutely not reliable. But this helps us to create a subdivision of levels of quality. For example, if we want to create something that is usable by academia, we can rely on primary and secondary sources. While if we want to just have non-academic education using the map or interacting with the data, we can use sources from all kinds of levels. Obviously, defining a single source as non-reliable. So we might have a building that is absolutely there because there is a paper that tells us that, or we can have a building that might be there because a paper says, because somebody says that it is there, but there is no reliable source. Which brings us to another aspect that is fascinating, being that the data is sometimes, this oral tradition can be sometimes used to be a starting point for research. So a very fast overview of the software architecture behind the system. Everything is completely open source. So every aspect is both on GitHub and as GitHub/Openstreetmap, and on Docker Hub as again Openstreetmap. All elements are Dockerized and written in Angular, and the backends are almost all in Python, and are almost all native in Python. We rely on on Mapbox.gl because of the old version was okay with transformation. We are going to change the version of Mapbox.gl to go to MapLibre because we want to use the 3D features of Mapbox. Let me show you very fast this slide about the infrastructure, which is quite complicated and interesting. If you want more details, we can. There is my email, I guess, in the last slides. But it's quite complicated, and on the 26th of November, we will have a conference where we have 4 hours where we discuss all the aspects of this technology. And let me just introduce you to show you a few of the last elements, which is, for example, the vectorizer. We started working with on the project made by the New York Public Library and open sourced in 2017, I guess, to vectorize their cadaster, 18th century cadaster. And we started working on that and evolving that towards a vectorization of the Gregorian cadaster. And obviously this map is absolutely unmanageable in that case, and for that we will be working in the next year towards a map digitization tool for users to do that by hand for unmanageable maps like this. But for example, for the Gregorian cadaster, it can be used, and it was used. And in this case, we have an overlay with the vectorized data, the original data, and some information collected from historians and architects and urbanists in Bologna in the last 5-6 years, as an open source open data package for the open data portal of the municipality of Bologna. So the results are several. This is, for example, the collection of the ephemeral data. We have a collection of ephemeral data, meaning that we collect events that happened in time and that have had impact on the world. For example, this is the Thor project, and this represents days during 1944 in the world, in Europe during World War II. This is, for example, the data from Kliwok, a climate project for ships that is based on ships in the 17th and 16th and 17th century, and it's beautiful because we can see the ships move. We can see the Endeavour move with James Cook leaving England and the Endeavour moving to New Zealand and going back to the United Kingdom. And this is all available at map.openhistorymap.org. Be kind, it's still a demo server. We are working towards getting it more structured, but it's already there. And you can you see the map at openhistorymap.org. We have also other information about the data index we are exposing. And let me just tell you one last element, which is the project that we're working on now. we have a historillary, meaning that we want to map photos from archives to elements in the map. For example, this is a historical map of in the area of Bologna around 2nd of August 1980. We have a set of photos collected in from the association August the 2nd, which collects all the victims and a lot of data about that moment, horrible moment in history of Bologna. And we mapped all the photos and the event itself on the map, giving us the possibility to create interactions and create and narrate the moment and the way the moment was perceived in time. And this opens up new ways to look at history and to new ways to look at how the world changed. So one last thing is that, well, yeah, nothing additional, honestly. If you have curiosities, the questions, openstreetmap.org, or you can just drop me an email and we can talk.
So, thanks a lot for this very fascinating talk. And I would like to thank you. And we are going to start again at 10:40 with the next speaker. So thanks a lot, Marco, for your participation.
Thank you very much.
Okay, so we can move on with the next speaker, who is Alexander Sander from the Free Software Foundation Europe. And he will tell us a little bit his thoughts, I would say, about what, so the future of free software also after this COVID situation. So Alexander, please, the floor is yours.
Yeah, thanks a lot. Thanks for having me. Thanks for the kind introduction. Yeah, as said, I will tell you a bit about the role of free software during the Corona crisis and also give you an outlook on what happens next. So that was quick. So for those of you who don't know us, the Free Software Foundation Europe, so we are a charity empowering users to control technology. And among these users are us, but also governments, public bodies. And this is what this talk is about and also what the Public Money, Public Code campaign is about. Roughly 1.5 years ago in March last year, borders have been closed. I think you all remember this. And Europe relies heavily on the principle of free movement, free borders, and traveling. So while borders have been closed to Corona, we had the situation that we needed to somehow open these borders up again, and software has been involved, which I'm going to show you later, and in particular free software has been used. Also, all of us have been working in home office. We are still working in home office, doing remote events, hybrid events like here, and also here we heavily relied on free software. And this is also what I'm going to show you in the next 10 and 15 minutes. So the universe needed free software, and free software helped during that time to tackle the crisis, and also will help us to tackle future crises. But first of all, what is free software? Free software gives you 4 freedoms. You can use, study, share, and improve. So, and whenever you have these 4 freedoms, then we call it free software. Sometimes it's also called open software, libre software, or so on. But whenever we have these 4 freedoms to use, study, share, and improve, then we call it free software. And this means you can use the software for any purpose without any restrictions. You can study the code, it's transparent, so anyone can analyze the code, can see what the software does. Also, you are free to share the software, again, without any limitations, and also the price doesn't matter. So free is not like free in beer, but you can also earn money with free software. And the 4th freedom is to improve or to modify the software. So everybody can not only see the code, but also contribute to the code, and by thus give back to the community. And this also doesn't mean necessarily that you need to be a coder to contribute. This is also something we will see in the next minutes. But also others can contribute to software, and this is also very important. To make it clear, I have a slide to show you the advantages of free software and the problems coming with proprietary software. First of all, with proprietary software, you don't have any interoperability, and this is a huge issue. So systems don't work together, you are not connected, so there is no interoperability, you're so in a very closed system, and this is also coming with a vendor lock-in. So whenever you buy proprietary software, you're stuck in a vendor lock-in, and you always need to go back to this one vendor to get APIs, to get updates, upgrades, and so on. And this is a huge problem, especially when you want to work together across borders. This also comes with unpredictable costs for maintenance. As said, you have to pay for updates and upgrades, and you never know in the beginning what you have to pay at one day, and thus you never know how much you have to pay in the future. And this also means your investments are lost because you have to pay for licenses as well. So whenever you buy proprietary software, you buy a license to get this, and when you want to work on another workstation, you have to buy for another license. So this is not the case if you use free software. And also what we've seen during the Corona crisis, just remember, for example, tracing apps, there's a low acceptance by citizens as the code is not transparent and you can't see if, for example, fundamental rights are protected. So this is also something we have seen during the crisis, that free software, open, transparent code gives you acceptance by citizens, and you also have security issues as you can't look into the code, and thus it makes you, gives you a hard time to find backdoors, for example, or other security issues. So the solution to all of these issues is free software, coming with the 4 freedoms. As you have open standards, you always have interoperability by default, so which is key if you want to work across borders, across languages. And also, you're very independent through free licenses, so you don't have to pay for a license. You just get it, and you are independent. You have these 4 freedoms. You can modify, for example, and so on. And by thus, you can also collaborate and share risks and costs. You can collaborate across borders, which is, again, key also for global crisis. And also, you can, on the other hand, involve local partners. So whenever you buy proprietary software, you go just to a vendor, then you get a piece of software and that's it. And mainly they are based in the US or in China or somewhere else. With free software, you can involve local partners. And we see whenever public bodies or governments procuring free software, then this is mainly done with local partners, which is also good for your local economy. And as said, we have this transparent code, so it's transparent by default, which gives you a lot of acceptance by citizens. And you can see, for example, if fundamental rights are protected, as you can see in the code, what's happening there. And this transparency also gives you the chance to search for security risks, so you can see what the code does and find backdoors, for example. And so what happened during the crisis? So we had this global problem, and on the same side, we need a global solution to tackle this, and software played an important role during the crisis. So these global problems come with mainly similar demands everywhere in the world. So they are slightly different, but it's more or less everywhere in the world the same demand. And this came with specific hardware and specific software we needed during the time. Just remember home office, but also these tracing and now the certificate apps. So this is something we heavily used in the last 1.5 years, these apps, but also for home office, video conferencing, what we are using here now. I think you use Jitsi as far as I see for hybrid talks. So this is also based on free software. So we heavily need software to stay connected to tackle this crisis. And the global solution again here is to use systems with open standards so that we can work together, where we have interoperability, where we can work across borders without any issues. And we need these free licenses with the 4 freedoms to use, study, share, and improve the code. And by thus we can collaborate and foster innovation, because there is no sense that every country makes its own solution, but we need one solution mainly fitting it all. Maybe we need to do translations, sure, but in the end it's mainly always the same solutions. And also we have seen during the debate, especially on the tracing apps, that transparency is key. So acceptance by citizens, they wanted to know what happens with their data. So it's health data we are processing, and thus we want to have a transparent code and see if fundamental rights are respected. And also this is key, we can involve all stakeholders. This means creating an app is not about only talking to coders and do coding thingies and have an app in the end, but we have seen that we need scientists from every area to tackle this crisis. And thus they can also contribute to this app, so all stakeholders can be involved in such a process of developing free software, in this regard, mainly apps to tackle the crisis. And on the apps, I want to give you some concrete examples what happened. So in the very beginning, this was also around March in the last year, we had this debate about the apps, should they be centralized, decentralized, open source, not, and stuff like this. And so we, very early, when we've seen that there's a debate and that there might be the solution going in the direction of app, we released 3 demands on these apps. So first demand is all of these apps need to be used voluntarily. This is very important. The second one is that they must respect fundamental rights. And to prove that they respect fundamental rights, we need this transparent code. And the third one is they shall be free software. So, and our demands were heard. That was very interesting. So for example, the World Health Organization released a paper in May 2020, just like 1 month after our press release on this, and after our lobby attempts on this. And they said, it's a very good idea, and all apps need to be full transparency, and the publication must be open source and open access of code. So the World Health Organization understood quickly that the global crisis can only be tackled with open source or free software. Also, the European Union followed us. There's an e-health network. The e-health network is the European Commission and the member states of the European Union. And they also released, back in April 2020, a toolbox for member states, what they shall do in order to release software to tackle this crisis. And here again, they recommended that openly published and technical specification and the source code of the apps as a way to maximize, and this is important, reuse, interoperability, auditability, and security. So they completely followed our arguments, and I think it's very important that they not just said, yeah, it should be somehow open source because it's good, but for example, that they use the argument on security. So we had the first time very strong papers coming from the World Health Organization, but also from European entities saying we need open source because of, and then these arguments came, which is very important. And then we have seen the development of the tracing apps, for example, so you can see the code. It was developed openly. I mean, still there has been some issues. For example, it was not available on F-Droid, a free software app store, and so volunteers use the code and make it available to everyone so that you don't need to have an Android phone, for example, but you can also use it with another free software operating system on your phone. But this was mainly doable because, first of all, we had free software here in place. Also for the COFPAS app, to get your certificates, some countries released them completely as free software. For example, in Switzerland, it was directly available on F-Droid. In Germany, again, we had to fix it with the help of volunteers to make it available on F-Droid. But this is mainly done because we have the chance with free software to modify and to make it available to everyone. And so this is key in the crisis to have free software. But what happened later, after we had all of these apps and all of the commitments, was in October 2020, the European Commission gave itself an open source strategy for the next 3 years called Think Open. And we awaited this strategy for a long time. And then we were a bit disappointed because it happened half a year after this strong commitment by the Commission to say, yeah, it must be open source because of security reasons and so on. But then, with this paper, they said, we want to have open source whenever it makes sense, so without explaining when it is like this. And also they introduced a loophole to allow them to choose non-open technologies where there are good reasons to do so. And this also remains open when such a situation arrives. So we see the strong commitment directly after the crisis was watered down in the next months. And then it happened that we got such a paper. Still, I mean, we have this open source strategy and we now have something for the European Commission where we can say, please follow this somehow. But again, at the same time, it's coming with a lot of loopholes, and also they want to set up a small program office to make sure that open source comes into the European Commission, so it's not a very strong paper they released. And so that's why we already before the crisis started a campaign called Public Money, Public Code, and with this campaign we demand that publicly financed software must be made publicly available under a free software license because it helps us all, not only administrations but also citizens. And there are very good reasons to have free software. So first of all, it's about digital sovereignty. So you should be in control over the systems you use, especially as a government, as a public body, as an administration. And also they are financed by taxes, so our money. And so if we pay for the software, it should be also available to us. And so that's why we released this campaign. And just a reminder, 25%, up to 27% of the revenue of software firms is generated by public bodies. So just imagine if we use this money to invest in software we need for home office, for example, because administrations are also in home office, we would have way better solutions than we see today. And so therefore, we have this campaign, Public Money, Public Code, already before the crisis, and it's going to be even more important after the crisis. So if you haven't supported, you can sign this campaign and support us with this campaign, and we are going to continue to lobby for free software in Europe. Thanks a lot.
Thanks a lot for this very passionate presentation and talk. And I think we can close here. If there are other questions, so you are free also to speak with the participants. And the next speaker will start at 11. Thanks.
There's also a booth over there if you want to come around on the FSFE where you can get some more information on this if you want. Thanks.
Okay, so let's move to the last speaker of this track, which was supposed to be Silvio Franceschi, but in his place it will be Andrea Antonello of the company Hydrologist, so which is located here at Neutech Park, and he's going to present an application called Smash. So Andrea, the floor is yours.
Thank you very much. Okay, yes. There's not much time to say who I am, but just know that I'm here to tell you a little tale. So once upon a time, there was a free and open source night called GeoPaparazzi. It was this application, it was a digital field mapping night. And it was, for many years, it was alone, it fought alone against the whole burden that was placed on the shoulders of surveyors. And they were forced to group into mobility groups when they had to do long surveys, for example, along a river, or when they were attached to some strange structure, putting them in danger, sometimes putting them in huge danger on their surveys. It attracted realms all over the world, so there has been contribution from FAO of the UN, from the Research Foundation of the State University of New York, and even from Osaka, from Japan, for a disaster management system. And even if these realms supported it, a terrible witch at some point cast a spell. And even after 10 years of activity, it had not been possible to overcome two huge issues. One was the fact that in some cultures, GeoPaparazzi, the name, was something really evil, like trolls or goblins. And the other one being the fact that there was no iOS version, just Android. And this was keeping aristocrats out of the game. So the round table of knights sat together, and after many years spent in fixing it, they came out with this version that was cross-platform finally. But what about the name? The name was still an issue, and they studied the market, and they found two things that happen today. One, a name needs to contain at least one buzzword. Otherwise, it won't work. And two, it should make people happy. So they come up with the final name that is Smart Mobile App for Surveyors Happiness. In short, SMASH. And this changed the whole thing, because the next generation GeoPaparazzi would be SMASH, a reviewed application that would work on Android and iOS. And it's an application still for doing surveys. It's used a lot also by hikers and Openstreetmappers, because you can just take your notes along the way and have it in your pocket. And very important, it works online and offline. It was born mostly to work offline. So what happens when you want to take a note? Well, you just pick on the screen, on the map, and you take your notes, you put a nice icon, you put a nice color, you write whatever you want. If you need to do it professionally, you most probably need some more structured forms. And that's how you can do them also. Well, you most probably also want to log some GPS information, record GPS tracks, and that you can do also. And you have some nice on-screen information, and if you want to analyze your log afterwards, you have a view to visualize your profile. And then you can also give some coloring, some theming to the logs, to maybe you want to see elevation, speed, because otherwise it's just a line on a map, and that doesn't make a lot of color in your world. You can apply filters if you have situations in which the GPS is a bit more nervous, and if you're surveying up in the mountains, then most probably I would suggest to also have contour lines on your backgrounds. There is support for various vector data formats. In read and write mode, we can access GeoPackage, which is a OGC standard, actually a standard, and PostGIS databases. You can also visualize GPX tracks and shapefiles, which is a GIS format, but only in read-only mode. There is support for projections in vector mode, so if you have data projected in some EPSG code, you can load them. They are reprojected also during editing. So you can really work with reprojected data. They are done on the fly. So you can edit your geometries, or you can edit your attributes table, the features you have in. And also for those databases, you can use the format if you have more structured data to work on. Raster data, we have the usual for mobile applications, which is tiled images, MB tiles, or geopackage. And we have a little support for geotiffs and imagery. And in that case also, it's possible to get them reprojected, but mind, because only the bounding box is reprojected. And that means that sometimes for let's say, quite warping projection, you could have strange results. If you are a surveyor, you most probably need to centralize your data if you're surveying in a team. And for that, we have a survey server, which is still bound to the name of GeoPaparazzi, because it's born quite some time ago. The GSS is also a free and open source application. You can put it on your server, and Smash can connect to it and synchronize the data to the server. If you are coordinating a survey, you can also upload your own projects, your own data, and your survey forms. So all the team can just, out in the field or wherever they are, they can synchronize and download the form that they want to survey with. One very cool thing of the server, in my opinion, is that you have support for versioning, which means if you take a node and synchronize, and then someone else takes over your work, and after a year it changes that node and synchronizes, you will be able to browse the history of that particular node. And that's very important for team surveys. The server itself allows to substitute the client. We made a default client, but for example, the Norwegian Institute for Nature Research, which is doing a pilot project with Smash and the server, they decided that the user interface was not what they needed for, it wasn't performant enough, so they placed Apache superset on top of the server. And it's very cool to see how everyone has its own view of the survey and how to visualize their data. If you have a tool like this, you usually need also supporting tools, because you need to prepare your data to go out in the field. You need to, when you come back, if you're a single surveyor, you need to convert them back to GIS data. And for that, there is a project that we also support in line with Smash, which is the Hoarder Machine. And it's an open source library. And it allows you, it supplies you with a couple of tools. One being the spatial toolbox that allows you to package MB tiles databases, geopackage databases, so you can just take your GIS data, if you are a GIS user, and place them into mobile format to take them on your survey. And to convert the survey back to GIS data. So you take your survey, your database from the mobile application, and you just convert it to GIS data to be used. There is a style editor, because if you're working with vector data, most probably you don't want them to have it just black. You want them to have colors possibly themed, and that's possible with that style editor. If you're doing structured forms, then somebody will have to package them for you, and that's what you do with this form creator, another application, where you can just visually add little pieces and structure your survey in tabs and buttons and combo boxes. There have been a couple of contributions already and external use cases, one of which is the location-based task manager. And I don't know if you know Redmine, the issue tracker. It's a quite well-known and very mature project, free software project for issue tracking. And this here is a plugin for that issue tracker for Redmine that allows you to connect directly from Smash to the issue tracker and generate not issues, but geo-issues. That means you have a nice map, you have a precise position of where the issue happens. So this is very, very useful to public administrations if they need to work on certain issues around town. The project has been developed by the guys at GeoRepublic, and they make it open source, and it can be found at that link that you see here. Another thing is that SMASH and the GSS server have been inserted in the official stack of the UN OpenGIS initiative, which is a project that started in 2016. And they started to build up a spatial data infrastructure that would meet the United Nations operational requirements. And this stack had to be completely open source, clearly. And so we have different parts, desktop application, web services, and then there is a part for digital field mapping, and that's where we have SMASH and the server in it. So that's quite cool also. Last but not least, SMASH is built with a library and the application on top. So if you need to do location-based applications that can exploit functionalities that SMASH has, then that's the way to go. You take the library and you modify just the app on top. And that's what we did with the Pilgrimage, the official app for the Pilgrimage of Assisi, which is completely based on SMASH. It's really just changing a couple of bits. And this app shows clearly a map needs to work completely offline. It shows you trails. It's a pilgrimage of 12 days. It's a hike of 12 days. So you can use this app to just look at the different places where you can stay and what you should visit. So actually, that's kind of all I have to say today. I have a couple of useful links for you, which is, well, the manual of SMASH, where you can find the sources of SMASH and where you can find the sources of the server. There is also a mailing list for users, and okay, it's quite readable, maybe orange on blue, next time not. This is the mailing list. If you have questions, you can just get to the list. Thank you very much.
Thanks a lot. Thanks a lot for this nice presentation. We have a couple of minutes left. Are there any questions from participants, from the audience? Okay. So if not, I would like to thank a lot, Andrea.
Thank you very much
for the presentation, and would like to close this track. Now we will have a break up to 12 o'clock, and then we will have one of the final track, which is the IOTA track. So thanks a lot for participating, and see you later. Thanks.